today we're going to take what we learned from the last lesson and we're going to use that to graph quadratic functions. So let's look at this. In order to graph these, we're going to first find the vertex. We're going to find the y-intercept and reflect it over the x-axis or the axis of symmetry. And then we're going to find another point and reflect it. So these are the 3 steps that you will be going through. So on our last lesson, we talked about how to find the vertex of a quadratic equation or the parabola. Remember this equation right here. We're going to find the axis of symmetry, which is the same thing as the x of the ordered pair of the vertex, negative b over 2a. So in our equation up here, we know that a is equal to 1, b is equal to negative 4, and c is equal to negative 5. So if we do the negative b divided by 2a, we're going to have the opposite of b, which is positive 4 divided by 2 times a. So x is going to be 2. The axis of symmetry is 2. Remember now we need an ordered pair for the vertex. So we're going to plug 2 back into the equation. When we plug 2 back into the equation, we're going to have 2 squared minus 4 times 2 minus 5. We always evaluate the exponents first. So you're going to have 4 minus 8 minus 5, which is a negative 9. And so we know that our vertex is equal to 2, negative 9. Now we know where the vertex is. So that was our first step, finding the vertex. Our next step is going to be finding the y-intercept. It's very simple to do. When it is written in standard form, the c term, the number at the end, is where it crosses the y-axis. It's called the y-intercept. So all you have to do is look up there and see that it's going to cross the y-axis at negative 5. So now we know where the vertex is, and we know where it crosses the y-axis. So let's see what we're going to do. When graphing it, we start with the vertex. We found that it was 2, negative 9. So we're going to put our vertex down here at 2, negative 9. We looked for the y-intercept and found that it crossed the y at negative 5. So we go to the y-axis and we're going to put a point at negative 5. Now we're going to reflect it. Remember that the axis of symmetry is where the vertex is. So we know that the axis of symmetry is on 2 right here. Because it crossed the y-intercept 2 to the left, to reflect it, we're going to put a point 2 to the right of the axis of symmetry. So we reflected it over the line of the axis of symmetry. Now, basically, we could graph it at this point. You can tell that the parabola is going to go up like this, but just we want to make sure we make it the right width. So what we're going to do is we're going to find one more point. Well, where do you start? Well, look to see where your parabola is going so far. And you can tell that the widest it is right now is at 4. So we know x is 4 right here. So let's just go one further out. What if x were 5? If x were equal to 5, we just went and plugged it back into the equation. We could find another one. So let's pick 5. When we plug that back into the equation that we have, we're going to have 5 squared minus 4 times 5 minus 5. We evaluate the exponent first. So you're going to have 25 minus 20 minus 5, which is going to give us 0. So we have another point now. We know that we have 5, 0. So if we put a point at 5, 0, we can also reflect it over the axis of symmetry. Since it's 3 to the right of the axis of symmetry, we can reflect it 3 to the left. Now we have 5 points. And I'm going to go back here because we are not done until we draw and have arrows at the end. Remember, it's going to look like a U going up. Okay, so there's our 3 steps. Find the vertex, graph it, find the y-intercept, reflect it, and find one more point. This one is one of your practices on page 66. So if you wanted to start looking at the examples on page 66, this is the first one. First, we're going to find the vertex. Remember, we start by finding what the axis of symmetry is, negative b over 2a. So when we do our negative b over 2a, whoops, let's go back. I've been showing you that. Let's do it. So the opposite of b is going to be negative 4 divided by 2 times a is going to be 2 times 1. So we're going to have negative 4 divided by 2, which is, let me write that up here. Let's plug it in. Negative 4 divided by 2. So we know that the axis of symmetry is going to be at negative 2. We're going to plug that back into the equation to find out what the y would be. So we have negative 2 squared. When we plug something in, we put it in parentheses. Plus 4 times negative 2 minus 4. Evaluate the exponent first. We would have 4 minus 8 minus 4. And when you do that, you are going to get negative 8. So we know y is equal to negative 8. So we know our vertex now. Negative 2, negative 8. So the axis of symmetry was negative 2. So we know that this is going to be where the axis of symmetry is because that's where our x was. On that axis of symmetry, we are going to go down here to negative 8. And we're going to put our vertex. Second step is to find the y-intercept. The y-intercept is the z. It's going to be negative 4. So when we go to the y-axis here, we can put a point on negative 4 because that's the y-intercept where it crosses the y. It was 2 to the right of the axis of symmetry, so we can reflect it to the left by going 2 over to the left. Now to pick one more point, I always look here and say, okay, here the x was 0. So let's go one wider and say that x is equal to 1. So if x is equal to 1, let's plug that into the equation. 1 squared plus 4 times 1 minus 4 is going to give us 1 plus 4 minus 4, which of course is simply 1. So we have another point now. We know y is equal to 1, x was equal to 1, so our next point is 1, 1. So we can graph 1, 1. It is 3 to the right, so we can reflect it 3 to the left. And now we can graph our parabola. Okay, so that's an example on page 66. Now, I'm going to skip on, there's another example here on 66, but I'm going to let you try that one and check it on your key. This is on the punchline 14.4. What you're going to do first is find the vertex. And when you look at your paper, you will notice that in the table here that there is down a ways on the fourth box, 1, 2, 3, 4. It looks like a little double-lined box. This is where you're going to put your vertex. So look on each one, you'll see the specially outlined box. First, we're going to find the vertex, and we're going to put it right there. So again, we do our negative b over 2a. So opposite of b is 4. 2 times 1 is 2. So we know that x is equal to 2. So here where our vertex goes, we know that x is equal to 2. That's our axis of symmetry. We're going to plug it back into the equation. So we have 2 squared minus 4x plus 1. I forgot to plug it into x. That's a 2. So we have 4 minus 8 plus 1. So that is going to be a negative 3. So now we know our vertex is 2, negative 3. And I'm going to put it in this special box right here. Let's go ahead and graph it. 2, negative 3. Now that you have it in this table, what you're going to do is you're just going to fill in the rest of the numbers, and it's going to look like a lot, but since we have symmetry involved, it's really not going to be that bad. So here's 2, so we're just going to count backwards now. 2, 1, 0, negative 1, so that it's going to count to negative 1, 0, 1, 2, 3, 4, 5. Now we need to figure out what the y values are. And you look at that and you think, you want me to do that 6 times? You don't have to do it 6 times. You can do it 3, because then when it reflects, you get the same values. So here's what I mean by that. To fill out the rest of this table, let's take the 1 right here. If x is equal to 1, and we plug 1 into the equation, we're going to get 1 minus 4 plus 1, which is going to be a negative 2. If this one is negative 2, we know that this one is going to be negative 2 because when you graph it, you reflect it. So we had point 1, negative 2. We know that we're also going to have 3, negative 2 because that's the reflection of that one over the axis of symmetry. So now if we plug in 0, 0 squared is 0, minus 4 times 0 is 0, it's just going to be 1. This one is also reflected, so this one's also going to be 1. So we know we have 0, 1, and we have 4, 1. Notice it's reflected over the axis of symmetry. If we plug in negative 1, you're going to have negative 1 squared minus 4 times negative 1 plus 1. 1 plus 4 plus 1 is going to give you 6, and that is also reflected right here. So we can graph that as negative 1, 6, and we also have 5, 6. And now we can draw our parabola. So try that and practice graphing, doing those 3 steps: finding the vertex, finding the y-intercept, finding one other point, and then on this side, find the vertex, put the vertex in the box in the middle, and then follow what we just did. Good luck with that.